Hi, I'm Karthik and Rannan. I'm the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it. Thank you.
Hi, I'm Karthik and Rannan. I'm the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, help the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me, so I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
Hi, I am Karthik Rannan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with advanced Excel over a span of 3 days. The workshop was almost 12 hours long. in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me, so I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical phase Atmos, and I thank XLR for being a part of it. Thank you.
Am I audible to all of you guys? Okay. Thanks for the confirmation, guys. So, yeah, thank you, guys. So, let me share my screen. Uh, is it visible to all of you? Okay, great. So, let's begin with the session, guys. So, in past couple of sessions, guys, we have done with the hands-on part with respect to the chat GPT. And we understood that what is a prompt engineering, all right? What are the different methods or techniques are there? And how you can utilize the chat GPT for, different tasks. So you can take help from chat GPT with respect to your business problems, even for social media case study, or you can even take help from chat GPT with respect to the data science part. So yesterday we saw how you can get the ready-made code from chat GPT, right? So with that, guys, and in the past sessions, we have also discussed something called as a neural network part, right? So in today's session, let's try to understand what is the technology behind the chat GPT, right? How you can understand like how chat GPT can respond. So basically in terms of the some technical details. So what is the model running behind the chat GPT and how it works? Okay. So, but up to the last session, guys, any questions, anyone? Shaswat, for that, like if you have any query related to the certificate part, so you can ask your query to Chandana at the end of session, right? So at the end of session, you can ask your query related to certification part to Chandana. Okay, so don't worry about that. Yeah, welcome. Any other questions, guys, up to the last session? YouTube guys, any questions? Okay, cool. There is one question from Biprajit. How can we ensure ChatGPT give us the right answer and not erroneous without first implementing the solution they gave us? So Biprajit, this is something we saw in yesterday's session. So like there is no guarantee that ChatGPT will provide each and every time 100% correct outcome. And yesterday we saw one of the example where we were trying to short our data set based upon some column. So if you recall, the column was the product name. But whatever answer provided by the ChatGPT, that was not correct, right? So ChatGPT was implementing some other logic. And you can even see what logic is implemented by the ChatGPT just by doing, just by, include one of the input as in your prompt, like provide step-by-step reasoning. So even if you open your ChatGPT account where you write your prompt, that means the input box. So below that input box, you can see there is a message written that ChatGPT can make mistakes. That is written from the OpenAI organization itself. All right. So that means there is no surety that you will get the 100% correct outcome each and every time. But yeah, most of the times ChatGPT provides correct outcome only. Okay. So ultimately, whatever output is generated by ChatGPT, you need to go through it, whether it is suitable for your business case or not. Okay. Yes, correct. Any other questions, guys? Anyone? Okay, so let me share my screen. So I hope my screen is visible to you guys. All right. So let's try to deal with some technical details, guys. Like what is the model running at the back end of ChatGPT, right? So if you guys recall, this is something we have already discussed that in the deep learning, we have a different neural network architectures, right? In the deep learning, so we have something called as a ANN, artificial neural network. So this kind of a neural network we use for regression or classification models. Regression or classification models. And we understood that how a typical neural network looks like, what are the other things are there. So if you recall, we have discussed what is the node or neuron, what is the weight, right? What is the typical processing is done by each and every neuron, how information is flowing from input layer to output layer, what is the activation function. So all of those things we have discussed. Then we have a second kind of a neural network architecture that is called as a convolutional neural network. So especially this kind of a neural network is for image data processing or image related task, image or video related task, right? Then we have a third kind of a neural network architecture that is called as a RNN or recurrent neural network. So this kind of a neural network is suitable for sequential data processing. And we also saw like what is a sequential data, right? So if you recall, so can anyone tell me what is a sequential data, guys? What is a sequential data? Anyone? Exactly, Bipraji. The data that follows a sequence. So here the meaning of the sequence is basically data is indexed by the time. All right. So that means you can't shuffle the records or you can't change the order of your data set. So under the sequential data, we do typically to kind of the modeling like time series forecasting. And generally we do time series forecasting with some numerical data. And then text data analysis. Text data analysis. So if you recall, at the beginning of this course, we have discussed something called as a NLP, natural language processing. And whatever we have discussed there, that was with respect to some machine learning based approach or some statistical methods. So if you want to perform the deep learning based analysis over the text data, that is something we are calling as a deep NLP. And this is the place where it comes to the deep NLP part. Deep NLP. That means perform the NLP related task using the deep learning or AI based methods or approaches. So here we treat the text data as a sequential data, right? We treat the text data as a sequential data. And how we treat the text data as a sequential data, this is something we are going to discuss in today's discussion, right? And then I have also explained you So due to some drawback with this RNN, we have the modified form of the RNN that is called as a LSTM, long short term memory. So these are the modified form of the RNN neural network, that is something called as a LSTM neural network. Even we have another modified form of the RNN that is called as a GRU, gated recurrent unit. All right, these two are the modified form of the neural network from the RNN. And then based upon the LSTM, actually, we have something called as a sequence to sequence model. Sequence to sequence model. So this sequence to sequence model is actually utilizing the LSTM network. All right. And based upon the sequence to sequence model, we have something called as a transformer with attention mechanism. So this is something, actually the model which is running at the back end of ChatGPT. I mean, based upon this particular model only, we are getting the response for our prompts, right? So to understand all of these things, so first of all, what we are going to do, we will try to understand the RNN architecture, right? And probably, if possible, I will also show you how you can build the RNN for time series forecasting. Okay, so that you guys can have a broad idea how this neural network is going to build. And then I will also discuss what is the difference between the LSTM and RNN architecture, and then how LSTM is used for sequence to sequence model. So this is the idea for today's session. Okay. So let's begin with understanding with the RNN neural network. So before starting with this part, any questions, guys? Any doubt? And by the way, all of this study material is uploaded over the LMS portal, guys. So I guess under the day 13, you can find this PPT along with some code and data set, right? So any questions, guys? Anyone? Or we are good to go? Okay, guys. So no questions. So let's start. So this is, guys, RNN is something called as a recurrent neural network. This is another kind of a neural network architecture what we have inside the deep learning based methods, right? So ultimately, we are dealing with the artificial intelligence only, right? So if you guys recall, what is the definition of the artificial intelligence, guys? Anyone? What is the artificial intelligence? What is the artificial intelligence, guys? YouTube, guys, what is the artificial intelligence? Exactly, machine mimicking the human behavior, right? So machine working human-like. Exactly, Nandini. Correct. Correct, Madhu. So let me just share it. So actually, what we are trying to do here in the AI, we are making the machine so capable that it can perform just like an human, right? So from there only, we have a different kinds of neural network architectures. So each and every type of a neural network architecture is somehow trying to mimic the human behavior. Let's understand from a human behavior point of view. So this is a typical human brain what we have, right? So if you see here, this larger portion, this particular part, this is something called as a cerebrum of a human mind. And below that, we have this small part that is something called as a cerebellum. So in that way, we have these two portion in our human mind, right? Cerebrum and cerebellum. If we just focus over this cerebrum part, like this particular portion, this bigger part, right? So within that, guys, we have a 4 partitions. So this light green is one partition, and this is something we are calling as a temporal lobe. This blue one is one partition, that is something we are calling as a frontal lobe. This yellow one we are calling as a parietal lobe, and this the pink one we are calling as a occipital lobe. So I mean, in that way, we have these 4 lobes in our human brain part inside the cerebrum. So that is something called as a temporal lobe, frontal lobe, occipital lobe, and parietal lobe. Now, what is the meaning of this portion? Actually, based upon the processing, data processing, and the functionality, we have these 4 parts. So if I talk about, let's say, this temporal lobe. So guys, this temporal lobe is nothing but this particular part of human brain tries to memorize the past information. Like if you guys try to recall some incidents which happened in your childhood, right? So probably you can recall couple of incidents, right? Or if you try to recall couple of incidents, let's say past 2 years or 3 years back, so you can recall couple of incidents or some memories just by this temporal lobe. So this temporal lobe will try to memorize the very past information like which happened in our lives, right? So those past information for a very long period, that is being memorized in this temporal lobe, right? And we have something called as a frontal lobe. So this particular part of human brain is try to memorize the incidents or the information which happened in a recent past, not very long time back, but in some recent past. So let's say 2 days back or 3 days back, or let's say 1 week back, right? Not years back, but in recent past. So whatever incident happened in a recent past, all of those incidents is being memorized by frontal lobe, right? And then we have something called as a occipital lobe. So this particular part of human brain is responsible for processing the images or videos or whatever scenes we saw in our day-to-day life. So like whatever things we saw from morning till night, all of this information as a images or videos is being analyzed by our brain just by this particular part of the brain called as the occipital lobe. So like this part is responsible for processing the images or videos, whatever we see throughout the day. So I mean, in that way, like these parts of human brain is performed. And if you recall, the definition of AI is something, but it is actually mimic the human behavior, making the machine so capable that it can behave just like a human. So now if I recall the different neural network architectures, so whatever architecture we have as ANN, artificial neural network. So we have discussed this part through hands-on also, and we saw that when we are building the artificial neural network, we are providing lot of data set to train our model. So that lot of data set tries to memorize what happened with the data set from very past, like long past years. So that means this is something which is a replica of the temporal lobe in our human brain. So just like the temporal lobe, which tries to memorize the past incidents, and this past incidents is couple of years back. Same like we have this ANN architecture where we provide the very past information to our model, right? And then guys, we have something called as a CNN, convolutional neural network. So if you recall, what is a convolutional neural network? So this is something which we use for process the images or videos. Process the images or videos. So it is actually the replica of this occipital lobe functionality. So whatever this particular occipital lobe is doing in our human brain, the same functionality is replicated by a neural network called as a CNN, convolutional neural network. So this C stands for the convolutional. Right? And then if I talk about this frontal lobe, so what this frontal lobe will do, it will try to memorize the recent past incidents. Not very long back incidents, but the incident which happened in a recent past. Let's say in the morning or last day or last 2 or 3 days, like that. So this particular functionality is replicated by a neural network architecture called as a RNN, recurrent neural network, which we are going to study in today's session. Right? So this recurrent neural network is a replica of whatever functionality is done by this frontal lobe. And then we have left with one lobe that is called as a parietal lobe. So let me tell you guys, this parietal lobe is responsible for whatever sensations or feelings we have. So all of those feelings and sensations is being analyzed by this part of a human brain that is called as a parietal lobe. So as of now, we don't have any kind of a neural network architecture that can replicate this functionality of human brain. That means we don't have any of the neural network as of date which can process the sensations or feelings of a human. Right? So I mean, in that way, like we have a different neural network architecture, and this is why we are calling AI is nothing but mimic the human behavior. So mimicking the human behavior is something replicating this kind of a processing in a neural network part. Is that clear, guys? Any questions, anyone? YouTube guys, any questions with this part? Yes, Kichu, correct. Okay, cool. So let's proceed, guys. So I hope this part is clear. So I'm sure now you guys can understand why we are calling AI as mimic the human behavior. Right? So this is the reason. So these are the details are here, whatever we have discussed. So whatever temporal lobe we have. So with respect to this temporal lobe, we have a artificial neural network, which is a replica of this temporal lobe functionality. So same like the frontal lobe, we have something called as a RNN. So it is like a short-term memory. Short-term memory means it can memorize the things which happened in a recent past. Right? So you will learn that they can remember the things that just happened in a previous couple of observations. And with that, it will apply the knowledge in going forward. Right? And then we have a occipital lobe, which is nothing but that is responsible for computer vision or recognizing the images, objects, or videos. So with respect to that, we have a neural network called as a CNN. And then the last one is a parietal lobe that is responsible for sensations, perceptions, constructing a spatial coordinate system, right? So I'm in the feelings part. So like as of now, we don't have any of the neural network that can replicate this kind of a functionality. So likewise, we have a different neural networks, right? Okay, guys. Now let's try to understand and focus on the recurrent neural network part. And we'll try to understand what are the different things are there. So actually, guys, whatever typical neural network we saw till date, so recurrent neural network is little bit different in terms of the architecture point of view from the artificial neural network. And let's try to understand how from an artificial neural network, a recurrent neural network can be, different. So let's see. So here I have taken, guys, a typical neural network architecture. So can you guys tell me how many hidden layers we have in this neural network? Anyone? How many hidden layers we have? Exactly, one hidden layer. Great. So guys, this is a typical neural network architecture what we have. Here you can see the first layer is the input layer. Last layer will always be the output layer. In between input and output, we have a hidden layer. So in this case, we have a one hidden layer, right? In my input layer, I have a 3 nodes. Hidden layer, I have a 4 nodes. In output layer, I have a 2 nodes. So in that way, we have this kind of a neural network architecture. Now let's apply couple of steps or couple of what you can say processing over this neural network. Let's try to see how we can get a recurrent neural network and what is the meaning of this term recurrent, right? So what we need to do, guys, just press this particular neural network from both the end. Just if you press this kind of a neural network from both the end, what will happen? It will get squeezed, right? So just squeeze this neural network from both the end. So this is the first step you apply over this neural network. So if you just squash this particular neural network from both the end, what will happen? So whatever, let me just show you from here. Okay, so let's see layer by layer. So if you squash this input layer from both the ends, so what will happen? These 3 nodes will, they will get on the top of each other. So if you squash this from both the ends, so it's like you have a one input layer node, the other input layer node on the top of this one, and the next input layer node will be on the top of these two, right? If you just squash this network from both ends. Same for all of
Guys, wait for 5 minutes. Yeah, 1 minute. Actually, because having some network issue. Okay.
Am I audible, guys? Guys, am I audible? Okay, thanks. Sorry, there was some internet issue from my end. Let me share my screen. I hope my screen is visible to you guys, right? Okay, cool. So let's see what we were discussing. So basically, if you squash this particular network from both the end, so what will happen? So this, instead of having these three nodes at the input layer, now I can see only one node and the rest of the two nodes will be on the top of this particular node only. So there will be three nodes, but if you see from on the top, so you can see only one node because the rest of the two nodes at the back side of this particular node, right? Same for all of these connections. If you just squash all of this connection, so it's like there will be only one connection you can see from the top, but rest of the connection will be at the back side of this particular connection. So same for this hidden layer nodes. If you just squash it, so instead of having the four nodes, you can only see one single node and all other three nodes will be at the back side of this particular single node. So I mean, in that way, if you just squash this network, the network will look like this, right? So if you see from the top or from the front, you can only see one node at the input layer, but actually there are two other nodes. So in total, three nodes. You can see only one connection between input layer to hidden layer, but all other connections at the back side of this particular connection. And same for this one, right? Then just do one thing. Just rotate this particular, architecture into a vertical direction. So instead of having the horizontal alignment, just do in a vertical direction like this, right? Gaurav, tomorrow we don't have any class, right? So we'll be having the next class on the Monday. Okay. Yeah. So this is how we are getting the vertical alignment of this particular network. Now here comes the role of, guys, the meaning of recurrent. So what is the full form? RNN is a recurrent neural network. So the meaning of recurrent is actually you must be having some feedback or memory, right? And why we are calling it as a memory? So if you recall the frontal lobe, so what frontal lobe will do? It will just try to memorize the recent past incidents, right? So how will this particular network will memorize the recent past incidents? Just by having some feedback or memory loop kind of thing. So that is something we do one, a special arrangement in this particular network, and that is called as this loop or feedback. That is called as a recurrent connection. So this particular loop is called as a recurrent, right? So this is something called as a temporal loop or recurrent connection. Now, if you see this particular connection, so in this particular architecture, what we have, this yellow one is something called as an input layer or input node. And guys, let me recall you, this is not a single node. At the back end, like at the back side of this particular node, we have a couple of other nodes. This blue one is the hidden layer node, let's say H1. And this is not the only node we have. We have other nodes at the back side of this particular connection, right? And then this red one is the output node. And if you just, see this particular recurrent connection, so actually this recurrent connection is starting from the hidden layer node and it is going to the hidden layer node only. But this, it is starting from the first hidden layer node and it will get connected to the next hidden layer node. So don't think that this particular connection is for the same hidden layer node. So it's like it starts from the first hidden layer node. So let's say this is the first hidden layer node. You have a couple of other nodes. So let's say this is the input node, output node. And whatever output is generated by this hidden layer node, that is being fed to the next hidden layer node. So that is the meaning of recurrent. That means we are transferring the past information to the next layer, right? So now if you just, open this particular connection. So initially we have squashed the connection. Now just unsquashed it. So just open it. So once you open it, so this is something you can see like this, right? So now what we have, so this is the first input layer node, first hidden layer node, first output node, second input node, second hidden layer node, second output layer node. So likewise, this connection will get expanded. And here, how you can identify the meaning of recurrent. So basically, whatever these connections we have. What are these connections? So these connections are nothing but, so this is the first hidden layer node. This hidden layer node will take input from the input layer node. It will do certain kind of a processing. And whatever output is being generated by this hidden layer node, let's say the node H1, that is being fed to the output layer node for further processing, as well as the same output is being fed to the next layer hidden node. So this H2. So for the next layer hidden node, we have a two input. One is coming from the previous layer hidden node and second input is a current input layer node. So if you see, except for the first hidden layer node, all other hidden layer nodes will have a two connections. So one is from the previous hidden layer node output, another one is a current input node, whatever information is there, right? So like this is a typical recurrent neural network architecture what we have. Is that clear, guys? How the RNN neural network will look like? Yes, Nandini, correct. Any questions, guys, to understand this part? How a typical RNN neural network looks like and what is the meaning of recurrent? So if you see here, so ultimately what we are doing, we are just carry forwarding the past information that is being, generated by these hidden layer nodes to the next hidden layer nodes. All right. This is what we are calling as a recurrent neural network. So any questions, guys? YouTube guys, any questions? Okay, so I guess this part is clear to you guys. So let me discuss a couple of applications of this RNN. Okay. Why we are squeezing the network? So Shashwat, this is how, we have this RNN neural network, right? So this RNN is something, if you recall, why we use the RNN? We use the RNN to process the sequential data. Sequential data, right? And what is a sequential data? Sequential data is something which is indexed by the time, right? So that means at time t1, we have first data, first record. At time t2, we have, or let's say not t2, let's suppose it's a t1 plus 1. at the next time instance, we have second data point. At t1 plus 2, we have a next data point. So likewise. So that means sequential data is something which is indexed by the time. And why we are squeezing it to get this kind of a architecture, so that if you see these input nodes, so actually based upon the time instance, we provide the input to this particular neural network. So it's like at time t1, we provide, this is input to the neural network. At time t1 plus 1, that means in the next time instance, this is the input to the neural network. And at the next time instance, we are also getting the previous hidden layer output, right? So let's say this is a ht. So at ht plus 1, we are getting the output from the ht and as well as the I of t plus 1. And at time t1 plus 2, this is the input to this particular hidden layer, and we are getting the past output from the this particular hidden layer node. So I mean, just by having this kind of a architecture, we can pass the input based upon the time instance in a sequence. That's why we are calling it as a sequential data. And let me also explain you why we are dealing with the text data as a sequential data. The reason being, so if you take let's suppose this kind of a input data. So let's say this is my text input data, what we have, let's say only this one, unrolling the temporal loop. And let's suppose I want to translate this particular text information into some other language, right? So what I will do, I will provide this particular text information as an input to this RNN, right? And this network will do whatever functionality it can perform, let's say machine translation and so on, for example. So how I can pass this particular text information as an input to this network? So actually this one is a sequential data. And why we are calling it a sequential data? Because let's say we have the first word unrolling at time t1. And after unrolling, you can get the second word. That is a D. So at time t2, we are getting the word D. At time t3, we are getting the third word, that is a temporal. I mean, you can't get the temporal before unrolling, right? So this part, whatever text data we have, that is in a sequence. So each and every word is coming after other word in a sequence. So what we can do, based upon the time instance, we can pass each and every word as an input to this particular network, right? That's why we are calling, this text data processing as a sequential analysis. Is that clear, guys? Yeah. Cool. So this is how we have a RNN as a recurrent neural network, and it is used for a sequential data processing. Now that's sequential data, it can be a text data or it can be a numerical data. Okay. Now let's see a couple of applications where actually we use this kind of an architecture. So the application of RNN has been classified as a one-to-many a kind of application, many-to-one kind of application, or many-to-many kind of a application. Okay, there is one question from Nandini. Why does it have to connect to the next hidden node? So any answer, guys? Why we have this? Why we have this particular connection to the next hidden layer node? Any answer, guys? Anyone? Why we have this kind of a connections, like connection from previous hidden layer node to the next hidden layer node? Exactly, in order to get the previous information. So let me just recall you. So if you just see what is the RNN. So RNN is a neural network that will try to replicate the functionality of frontal lobe in our brain. And what this frontal lobe will do, it will just store the short-term memory. That means whatever incident has happened in a recent past, all of this information is stored in the frontal lobe. So how the recent past information will be stored? So it is a sequential, right? So based upon the like time to time instance, it will try to relate the incidents and it will try to store the information. So the same functionality is being done by RNN. So if you see here, whatever processing is being done by this first hidden layer. So after processing, it will generate some information. Ultimately, whatever output is being generated, that is containing some information. So that information is passed to the next hidden layer node, so that this particular information is present at this particular time instance. And then this node will perform some other processing. It will generate some other information that is passed to this particular node. So that at this particular time instance, let's say T3, the information, whatever past information is there, that is present at this particular time instance. So if you don't have these connections, how you will carry forward the past information to the next time instance? Because ultimately it needs to memorize the things, what happened in the past, right? So that's why we have these connections. Cool. Okay, thanks guys. Any other questions, guys? Anyone? YouTube guys, any questions? There is one question. What happens in the second input and getting the previous output from the hidden layer? What does into the output? So output layer is exactly same, Kichu, what we have discussed in the ANN part, right? So if you see here, let me share my screen. So if you see here, so for this particular hidden layer node H2, let's say this is H2, it is getting two input. One input is from the previous hidden layer output. Another input is the current input data, whatever input data at this particular time instance T2, let's say. So this is a T1, T2, and T3, and so on. So based upon these two input, it will do certain kind of a processing. And whatever output is being generated by this hidden layer node H2, that is passed to the output layer node as well as the next hidden layer node. So this output hidden layer node will perform exactly same functionality what like other nodes will perform, like adder function, and then based upon the activation, it will generate the output. Right? So the output node functionality is exactly same. Okay. So now let's see, guys, what are the different applications of this RNN? So we have something called as a one-to-many application, where we have a one input, but in the output we have a like we have a many outputs. That means multiple outputs. For example, like providing a caption to an image. Let's say I want to provide a caption to image. So what I will do, I will pass this particular image as an input. So input is a one single image. That is the one input, right? So this is my input layer where I will pass. Here I will pass my input image, right? So input is one single image. But what is a caption? Caption is a sequence of words, right? So what this RNN will do, it will generate the caption, and how it will generate. So each and every output layer will generate one word. So let's say this is the caption: black and white dog jumps over bar. So this black, this particular word is the output of the first output layer node. So this output layer node will generate the black. Second output layer node will generate the and. Third output layer node will generate the white. So likewise, we have a multiple outputs. So ultimately, we will combine all of these words, and this combination of word will become a sentence that is the caption for this particular image. So we have a one input that is a single image, but in the output, we are getting the multiple outputs as these individual words, right? So in the output, we have a sequence of words. That is a caption to this image. So this is something we are calling as a one-to-many application. Clear, guys? And these are the some real-time applications, right? So most of the times we use the RNN kind of architecture like this kind of applications only. Okay, so this is one of the application. Then we have a something called as a many-to-one application. So the best example of many-to-one is a sentiment analysis. So what is a sentiment analysis? So here we pass the whatever input data we have. So in the input data, it can be tweet, or let's say it can be feedback or review, anything. So if you take just one tweet or one review, so what is a tweet or review? So it's a combination of, or it is a sequence of words, right? For example, let's say I have a review like this. This food is tasty. So let's say I have a this particular review, and I want to perform the sentiment analysis for this particular feedback or review. So this particular feedback or review is a sequence of words. And just now we have understood why we are calling this text data as a sequential data analysis. So what we do, we pass each and every word as an input to this sequential RNN neural network, right? So at time instance T1, we have a first word that is a this. So this is the output, like this particular word is the output to the first hidden layer node. And then it will do the processing. And based upon that, whatever output information is being generated, it is passed to the next hidden layer node. So at time instance T2, we have a second word, food. So based upon the past, like the previous hidden layer output, let's say H1 output, this node H2 will perform some processing, taking these two inputs. It will generate the output that is passed to the hidden layer node H3. And the here at time instance T3, we have an input is. Then at time instance T4, we have a input as a tasty. And then likewise, the processing will be done. So just ignore this one. So here we have a final output layer. And the output of this H4 will be the input to this output node layer output node, and it will perform the processing and it will generate the final output as a sentiment, whether it is a positive or negative or neutral. So if you see, my input is a sequence of word, but output is a one single word. That means there is a only one output, either positive or negative or neutral. So our input is like I have a multiple input, but only one output, right? So just like this. So this is a sequence of words, which is the input. And then I have a final output as a one output, either positive, negative, or neutral. So this is a typical example of many-to-one application. Then we have also like many-to-many application. So a typical example of many-to-many application is a machine translation, where you have a sequence of word in a one language, and you want to translate this sequence of words from one language to another language. So in another language also we are getting some sequence of words. So let's say English to French, right? So this is a typical example of many-to-many application. And these are some real-time examples, guys. So generally we use this kind of architecture for these kind of a task only. Okay, is that clear, guys? Any doubt, any questions? YouTube guys, any doubt? Is that clear, guys? Okay, so if this part is clear to you, so before proceeding further, guys, let me also show you how you can build a typical neural network architecture like RNN over some numerical data. So this time I'm showing you with the numerical data, right? So that means as a time series forecasting part. And there I will discuss you like how RNN will process the input data, how it will take the input data, right? And what are the other things. So for that, guys, I have already shared the like Python notebook as well as the data set. If you're interested, you can open the same in the Zipton notebook, right? So just give me a minute so that I will be ready with the Zipton notebook and the dataset part. So meanwhile, you can also open the Zipton notebook and the code file. Okay, guys, so let me share my screen. I hope my screen is visible to you guys. And let me repeat it again, guys. So this Python notebook is already there over the LMS. I guess under the day 13, you can find this notebook as well as the dataset. All right. So let's see, guys, how we can build this RNN neural network. So actually, okay, I will come back to that point later. So let's see, guys. First of all, I am importing the required libraries like NumPy, Pandas, and Matplotlib. So this is something we use for a like visualization purpose. And then this is our data set. So basically, this is a very famous data set. That is a Google stock price data set. And we have a two data set. One is the train data set. Another one is a test data set. Right. So this time, no need to, do the splitting of your original data. You're getting the train and test data set separately. So what we do, we build the model over training data set, and then we test our model over the testing data set, right? Okay, so this is what we have a Google stock price data set. Here we have a date. So date wise, what is the open price, highest price, low price, I mean the lowest price, closing price of this Google stock, and then the volume of stocks. So if you see this particular data, this data is indexed by the time. And what is the time? Date. So for each and every day, I have these records for open price, highest price, lowest price, closing price, and total volume of the Google stocks, right? So, I mean, this is something we have a sequential data. You cannot shuffle this data. The reason being, let's say you make the second record. If you make the second record as a first and the first record as a second, you can't do that. The reason being, if you see for the second record, the date is a, I guess it's a 4th of Jan. And if you just take it on the top and the first record will be on the second. So like you are saying, first of all, you're getting the stock data for 4th of Jan. And then you're getting the stock data for 3rd of Jan. That is not possible, right? Time cannot be reversed. So that's why you can't shuffle this data. And this data is indexed by the time. That's why it is a sequential data. Okay. So over this data, guys, we are going to forecast this closing value for the Google stock price. So we will leave all other variables and we will be going to going forward with this close variable. So we are interested with forecasting what will the closing price for next couple of days. So this is what we are doing. We are just selecting this closing price, this close variable from our training data, and I'm sure you guys can understand the syntax of iLog, right? So this is our training data of the closing price. So you can see the first record. I guess okay. So I guess we are processing with the open price. So sorry for that. We are going to forecast this open, open column, open feature, right? And this is the values of the open features, right? And then if you recall, guys, from the neural network point of view, we understood that before building the model, you need to scale your data set or standardize your data. That is something called as a feature scaling, right? This is also we saw when we are building the artificial neural network. So this is how we are standardizing our this particular data, which is a open price data, and this is what we are getting as a standardized value for my open column, like open price for the Google stock, right? Now over this particular data set, we need to build a RNN architecture model that will forecast the open price for next couple of days. Now, guys, when it comes to building the RNN neural network, here the data processing is little bit different from rest of the neural network. So, like for rest of the neural network, what we do over this data, we directly build the model, and then we directly test the model over testing data. That's it. But in case of RNN, since RNN tries to memorize the recent past information, so here there is a one concept called as a time stamp. Time stamp. Time stamps, or it is also called as a window size. Window size. So actually, this is something you need to specify, like how many past time instances you want to memorize for each and every hidden layer. That means if I specify here, let's say, let's suppose 10. So what this network will do, it will only memorize the past 10 time instance information. And this data is on a day wise, right? We have a day wise data. For each and every day, we have a open, close, high, and low price. So that means if I specify time stamp or window size is 10, that means this RNN network will try to memorize the past 10 days information only. Okay. If I make the time stamps of window size, let's say 50. So this RNN network will try to memorize the past 50 days information. So I mean, in that way, we have this concept of the window size or time stamp. And based upon this window size or time stamp, it will, it will do certain kind of a processing with the input data. And what kind of a processing will do? Let me just show you. So let me just explain you like this. So let's say, guys, my time stamp is TS is, let's say, 3. Let's say I have a time stamp as a 3. And these are the values, right? So let's suppose this is the first value, second value, third value. This is the fourth value, fifth value, and sixth value. So how it will, create a data set based upon time instance, what it will do? It will take first 3 records as the input record. So it will create a data set like this. It will create internally a data set like this: x1, x2, x3. 3 x variable based upon your time instance value, and then 1 y variable. And then what it will do, it will take the first 3 data point as the x1, x2 and x3. So it's like 0.85 is the x1, x2 will be 0.97, x3 will be 0.94, and then y will be the next data point, which is a 0.95. So this is the first row for this RNN neural network. It will treat these x as the independent variable and this y as a target variable. So this is the first record. Second record, what it will do, it will take the next 3 records as the x variable and the next record as a y variable. So what is the next 3 records? So just shift it by 1 unit. So the first record will be 0.97. That is this one, 0.97. Second record will be 0.94. Third record will be 0.95. And the next will be the target variable y, which is a 0.93. And what will be the third record? So just shift it by 1 more unit. So let me just clean it. So for third record, it starts from here. So it will take the first 3 records as the x variable, so like 0.94. x2 will be 0.95. x3 will be 0.93. And the y will be the next value, which is a 0.936. So I mean, in that way, it will internally prepare the data set based upon your time instance value. And what it will do, it will treat all of this x as the input features. And based upon that, it will try to forecast this y value. Is that clear, guys? How the data processing is being done by RNN at the backend to build the model? And this is how it will try to memorize the information. So if you see, whatever value we have a x2 in the first record, that is the x1 in the second record. x3, that will be the x2 in the second record. Whatever y we have in the first record, that is the x, that will become the x variable in the second record. And same like this. So this is how it will try to memorize the information. So it totally depends upon what is the time instance you have provided. Guys, is this part is clear or what? YouTube guys, is that clear? The data processing for RNN. Kichu, window size will decide how many recent time instance you want to consider. Right? Guys, attendance link will be there by 8:30. Okay. So attendance filling time is from 8:30 to 9 p.m. So don't worry, by 8:30, you guys will get the attendance. Okay. Any questions, guys, with this part? Anyone? Okay, so if this part is clear, then rest of the things are exactly same what we have already done. So here you can see, guys, the data processing for RNN. So we have specified the time instance here, the 60. Right? So it starts from the 60 and goes up to the last index position. And this is how it will prepare the X train and Y train. Right? So whatever I have just showed you. So like these are the different X values. So for each and every record, we have a 60 values. And like after 60th value, whatever we have, that is the Y. right? So I mean, in that way, this X and Y data set will get prepared, and then it needs to reshape the X train and Y train, like X train and X test data. So it accepts the data set into this particular form. So like generally we have a like rows and columns representation, but this RNN will take you need to reshape this data into this form. So first of all, you need to have a batch size. That means total. So like what is the total number of rows for your X train? Then you must have a what is the time instance, which is the like the number of columns. So number of columns is nothing but after getting the pre-processing. So you will get the here you have a 60 as a number of columns based upon the time instance. And then indicator is nothing but how many target variable you have. So we have only one target variable which we want to forecast. So I mean, this is you need to reshape your X train as well as the X test. So it takes the data set in this particular size, right? And then the rest of the things are same. So we are just taking the sequential model. And generally, when it comes to the building the RNN, so actually we build the LSTM, right? The reason being, we have some issues with the RNN neural network. So we avoid building the RNN. So instead of RNN, what we do under the keras.layers, we have a LSTM model available. So we just build the LSTM model instead of RNN. So you will never find like a project where you can which is based upon the RNN neural network. So when it says the RNN, that means we are building the LSTM actually. And then the number of nodes, and this return sequence equals to true is nothing but, guys, that will indicate that the output of one hidden layer node will be the input to the next hidden layer node. So this particular connection is being stabilized by this particular argument return sequence equals to true, right? And then just pass the input shape. So this is how you can build the model. And this dropout is nothing but, guys, this is what we have. Like let's say you have a input layer and hidden layer like this. And let's say you have all of the connections. So this dropout, what it will do? Here we need to specify some percentage. So here I have specified 20%, right? So dropout of 20%. 20% is nothing but 0.2. So if I specify after this layer, if I specify here the dropout, that means out of total number of connections, it will drop 20% connections randomly, right? Out of total connections, it will randomly drop the 20% connections. By doing this one, actually, we are ensuring that the model will not be too much complex, right? So basically, there is something called as a overfitting issue. So to avoid that overfitting, we are just introducing this dropout layer. But rest of the things are exactly same. So like the first hidden layer and second hidden layer and all. And finally, we have an output layer. And then this compile this particular network with optimizer as item and loss function mean squared error. So since we are forecasting for a numerical value, so here my loss function will be the mean squared error. And then just fit the model over X train, Y train. Just mention the epoch and batch size. So we have already discussed what is the epoch, what is the batch size, right? So this is how model will get built. And then once model is ready, what you can do, take your text data and first of all, do the same processing with the text data, whatever we have done with the train data. That means based upon the 60 time instances, just prepare this data and then do the prediction over this X data. And after getting the prediction, what you need to do, you need to inverse transform your target variable, because if you recall, before model building, we have transformed our data set as a feature scaling part, right? So we don't need this scaled values. What we need this original values. So that's why we are inverse transforming our predictions. And this is how you can get the, so this is the real stock price, what we have. And against that, we have this forecasted values. So I mean, this is how you can do the forecasting. And you can see here, like you can even get a visualization for your forecasted value. That means the predicted, this blue line, and what is the actual. So you can see the pattern is more or less is followed, right? So I mean, this is how you can design a typical recurrent neural network architecture. Clear, guys? Guys, don't worry, attendance link will be there by 8:30. So please wait for that. There is one question from Saswat. Are the number of hidden layers decided by us? Yes, Saswat, this is something we have already discussed, right? So you can go to the recording. So there we have discussed like how many number of hidden layers will be there and how many nodes will be there. So this is something you can decide. Okay. So if you want, let me just go through. Okay. So if you want, you can add couple of more layers, or if you want, you can remove any one of them. So it's up to you. Any other questions, guys? YouTube guys, any questions? Okay, there is one question from Kichu. So basically, difference between the min-max scalar and standard scalar. So Kichu, actually, okay, let me just share my screen. Okay, so Kichu, if you see, both min-max scalar, let me just show you from here. Okay. Both min-max scalar or standard scalar, both will do the feature scaling, right? You can choose any one of them. But if you typically ask me what is the difference between these two, so the difference is basically how they are, transforming this data into like these values. So actually, standard scalar is using the formula of z score, which is nothing but x minus mu by sigma, where this mu is the mean of that variable, mean value, average, that is the average value. Sigma is the standard deviation of this particular variable, and x is the every data point. So just put all of these values. So for each and every x values, you can compute this particular score, and based upon the z score, it will provide the translated data set, right? So by standardization, like you may get the positive values, or you might get the negative values also, right? So as such, there is no limit that in between that you can get the values. From standardization, you can get any value. But when it comes to the min-max scalar, that is also called as a normalization. So it uses the formula like this: x minus the minimum value of the variable divided by max value minus minimum value. So I mean, this is the formula used by the normalization method or this min-max scalar to transform your original data into this particular form, right? And one thing to note here, whatever values you are getting after normalization, all of those values will be in between 0 to 1 only. So that is being guaranteed by this normalization. But you can adopt any one of the approach. So in the final outcome, there won't be too much difference. You can go with any one of them. So, but like this is a typical difference between standardization and normalization. Is that clear, guys? Any other questions, guys? Kishu, does it resolve the queries or what? Any other questions, guys? Anyone? Okay, so there is one question: how to identify error in data when complex? What does that mean, Suman? Identifying error in data when complex. That what does that mean? Will you please elaborate your question? Guys, attendance link is there in the chat box. You can mark your attendance. Okay, so another question from Kichu. Why was LSTM being used here? So Kichu, it's a LSTM, not ISTM, right? So why we are using the LSTM actually? Generally, we avoid building a model using RNN. So there are a lot of issues with the basic RNN network. That is something we will try to explore in upcoming sessions, right? So when it comes to the building the RNN, by default, we are using the LSTM model. Okay. Probably in the next session, I will show you the difference between the RNN and LSTM. Okay. So just take it like this. When it is being said to design a RNN network, we use the LSTM only. What kind of a error, Sumant, you are asking? Like which kind of a error? Like at what part? YouTube guys, any other questions? Okay, Sumant. So in repeated or duplicate values and so on. So Sumant, this is something like we have a different methods. So if you recall the Python hands-on part, like the first 2 or 3 classes, right? So there we have done all of this exercise. How you can, identify the missing values, or how you can, identify the duplicate records, or how you can remove the duplicate records. All of those things we have done in the first 2 or 3 sessions. Okay. So here I'm not, doing that part because we have already covered that thing. So we are actually saving the time just by avoiding that part. But yeah, that is something you can apply over the data set to identify whether there is any duplicates are present or not. Okay. Harshada will be having that MCQ based exam. So that is a surprise test. So whatever classes we have left, probably in those sessions, you will be having that exam. Okay. So don't worry about it. That will be there. And that will be only MCQ based. Okay. Okay, Kichu. So there is one more question, guys. Explain the loss function mean square error. So let me share my screen. Okay, so see guys, the question is, if you see this RNN neural network, and here in the loss, I have used something called as a mean squared error. So let's try to understand what is this particular error. And let me just explain you like this. So if I ask you guys in general, what is the error? Forget about neural network and deep learning and all. In general, what is error? Anyone? Yeah, which contains the mistakes, right? So error is basically, if I just simplify, error is nothing but that is a difference between your actual value and whatever you have, let's say, as a calculated value. For example, so whatever value you have calculated and the difference from the actual. So whatever is the difference, that is the error actually, right? So when we are predicting or forecasting any numerical value, so like in this case, we are just forecasting any numerical value, right? So here we take the error as a mean square error. So what is this mean square error? So if you see, we have a three terms. One is the error, another one is a square, and then mean. So if I just, break down all of these three terms like this. So if you see here, guys, this is my real values. That means the actual values. And these are the predicted values, right? That means the so what is the mean squared error? Predicted value, let's say pred, and then take the square of this error. So whatever error we are getting, just take the square and then take the mean. So this mean is actually, since we have a number of actual values and we have a number of predicted values, so just divide this one by total number of records, right? So that is something, let's say we have n, and since we are getting the prediction and actual for different time instance, right? Different records. So just add each and every difference squared for each and every data point. So I mean, it's like this. So for the first data point, this is the actual and this is the predicted. So what is the mean square error for the first data point? That is so for the first data point, it's a actual 778 minus 772, that is a predicted. Take the square, that is the squared of error. Then for the second record, what is the actual? 788 minus what is the second predicted? 769. And then take the square of that. That is the square of error. And let's go up to the third data point. So what is the third data point? Actual value 795 minus predicted 770. Take the square. So if you just solve it, you will get some values. So let's say here we are getting x1, or let's say the n1, n2, n3. So some numbers you will get, right? If you just solve it. And then take the summation of all of this n1, n2, n3. So let's say we are getting the n4. This is something we are calling as a mean squared. Sorry, this is the squared sum of squared error. Just divide this n4 by 3 because we are taking the 3 data points. So if you just divide this n4 by 3, you will get, let's say, n5. This n5 is something we are calling as a mean squared error. In short, it is called as a MSE. Mean squared error, or MSE. So this particular error we use when we have a numerical value as an actual and we have a forecasting or prediction for a numerical values. Is that clear, guys? What is the mean squared error? So based upon this value, you can identify how much is the difference between the actual and predicted. Right? So in that way, we have this kind of a error. Is that clear, guys? And any questions? Kichu, is it resolved or what? Is that clear? So I have explained, like, even I have told you, the exam will be in the rest of the session, right? So it may be on the next session or next session. So we left with the 2 more sessions. Okay. So either it will be on Monday or it will be on Tuesday. Clear, guys? Not only for time series Kishu. So whenever we are doing the forecasting or prediction for a numerical value, you can use the MSE. Okay. So time series forecasting is one of the application. Okay. So okay, any type of mathematical operation can use. For what, Sumant? For what you want to use the mathematical operation? Okay, so if that is clear, guys, let me share my screen. So this is what we saw, the RNN. So Suman, actually depends upon like what kind of processing we are performing with the data. So based upon that, there are certain mathematical operations are involved. Like from application to application, it is differ, right? Okay, so we saw, guys, how you can build a typical RNN neural network and how you can do the forecasting part with the numerical data. So apart from that, guys, if you recall, so I have told you, like when it comes to the building the RNN, actually we build the LSTM model, right? So what is the LSTM and how it is different from RNN? That is something I will discuss in the next session probably. But before that, let's see what is a sequence to sequence model. Because ultimately, sequence to sequence model is nothing but it is utilizing the LSTM model at the backend. Right? So based upon the LSTM only, we have the sequence to sequence model. And this kind of a model is especially built for to deal with the sequential text data. Right? So we have a something called as a sequence to sequence model. Sequence to sequence model. This kind of a model we mainly use to deal with the sequential text data. So like machine translation or whatever other task you want to perform, that is something you can do with the sequence to sequence model. Here it consists of two RNN model. And again, guys, when I say the two RNN model, actually it's a two LSTM model, right? The first part is called as an encoder. Second, we call it as a decoder. So this kind of a model we use for machine translation, text summarization, speech recognition, question answering system development, like that. So basically, especially for a text analysis. So let's try to see like how this architecture will look like, the sequence to sequence model. So the architecture is like this. So we have a encoder block, we have a decoder block. Encoder is a block where we pass or where we provide our input text data, and since it is a sequential data, so for each and every time instance, we provide one word as the input. So input is a sequence of word. And this decoder will generate the output at different time instances. So let's say T1, T2, T3, and let's say this is a T4 time instance T5, T6, T7. So for each and every time instance, the decoder will generate one word as output. So in the output, we have a sequence of word. So if you see, input is a sequence of word, output is also a sequence of word. That's why we call it as a sequence to sequence model. My input is a sequence of word, output is also a sequence of word. So that's why we call it as a sequence to sequence model. And if I typically like explain you like this encoder and decoder network. So actually this particular box, this encoder box, here we provide our input, and this encoder will contain number of LSTM models or LSTM cells. We have a different like number of LSTM cells here or LSTM model. They will perform the processing and they will generate a final outcome that is something called as a context vector. This context vector is nothing but whatever information is being captured by these LSTM cells based upon this input. that is being represented by this context vector that is passed to the decoder. Decoder will again contain some LSTM models or LSTM cells. It will take this context vector and it will try to generate the output words. So like this is a typical like encoder decoder architecture what we have. All right. Guys, attendance link is already there in the chat box. Please check your chat box. Okay. And if you see, so this is what we have explained you. Okay, so this is a typical, explanation. So this green box is something we have an encoder block. The second block we have as a decoder block. Right. So in the encoder, let's say we have a 4 LSTM models, right? And let's say we are performing something called as a machine translation. So my input is a sequence of word nice to meet you. So at every time instance, we have a one word as an input. So at time instance T1, the input is a nice. Time instance T2, input is a 2. Time instance T3, input is a meet. Time instance T4, input is a U. And what we do, this LSTM will generate, like this hidden layer, whatever hidden layer node we have, this hidden layer node will do the processing and the output is passed to the next hidden layer node as well as the output layer node. Whatever output is being generated by each and every LSTM cell, that is being discarded here. So we don't take this output. What we do, from the last LSTM cell, whatever hidden layer output is being generated, that is something we are calling as a context vector, and that is the input to the decoder model, like this decoder part. In the decoder, again, we have a number of LSTM cells. And what this decoder will do, so the first LSTM cell, it will take this context vector from the encoder block. It will do the processing and it will generate the first word as the output, let's say Ravi. The second LSTM cell, it will take the hidden layer output of the first LSTM cell as an input, and the second input is this particular output. This Ravi is the second input to this second LSTM cell, right? So whatever output is being generated by the first LSTM cell, that is the input to the next LSTM cell. Whatever output is being generated by this next LSTM cell, that's the D, that is the input to the third LSTM cell, and the second input for the third LSTM cell is the hidden layer output from the second LSTM cell. So I mean, in that way, this decoder network is being arranged, and this is how it will, generate the sequence of word as the output. Now tell me, guys, if you see this encoder network, what we have an input, this particular words. This is a text information. So can I pass this words directly to this network or what? What do you think? Can we pass this text information like this word as a text form, like nice to meet you, directly to this network? Or we need to do something else? Do you guys recall the NLP concept? YouTube guys, what do you think? Anyone? Can we directly pass this text data as an input to this LSTM model? No, right? We need to convert this text data into the numerical representation form. So I mean, we need to apply some kind of a method to transform this text data into the numerical vector representation. So if you guys recall, we have discussed something called as a count vectorizer, TF IDF vectorizer, right? So that part is already there. And then I have included a couple of details regarding the this encoder decoder block, right? Is that clear, guys? Yes, Kichu, vectorizer, right? Okay, so this is what, guys, we have a sequence to sequence model. Okay, so we have discussed something called as a RNN and sequence to sequence model. Probably in the next session, I will show you the difference between the RNN and LSTM so that you will be having a very clear-cut idea. All right. And then we will try to see a couple of more functionalities of the ChatGPT. All right. So this is the idea for a couple of next couple of sessions. So any questions, guys? Anyone? Attendance link is there, guys, in the chat box. Please mark your attendance. And all of this study material which I have used for today's session already available over the LMS under the day 13. Amrita, not all of these models, but like we have a something called the transformers, which is the modified form of this sequence to sequence model. So to understand that, it is very much required to understand first RNN, then this sequence to sequence model, and I will also discuss something related to the LSTM so that you can understand how this transformer is being built, right? Okay. Any other questions, guys? Anyone? Cool, guys. So if you don't have any question for me, over to Chandana. If you have any question related to the LMS study material or certification, so you can ask your queries to Chandana. Over to you, Chandana.
Yeah, thank you, Vikas. Guys, do you have any queries? Please let me know in the chat box, and I'm sharing the attendance link. So please mark your attendance. And one more announcement from my side that on Monday we don't have a YouTube live. Okay, we are not live in YouTube. So I'm sharing the Zoom link over the YouTube and Zoom. So please join via Zoom on Monday. Okay. Nandini is asking, ma'am, do Exceler have internship program? Yes, we have. So please drop an email to edl@exceler.com. Okay. My team will contact with you. So guys, is there any questions for me? And I'm sharing that mail in chat box also. Please take from there. Okay, then I hope there is no more questions. And one more thing, tomorrow and day after tomorrow, we don't have a class because weekend, right? That's why. Sumanta, if material is not updated, means we will update, okay? By tomorrow. Okay. So I hope there is no more questions from YouTube as well. So we'll wind up the session for today and we'll meet on Monday, okay? Up to then, take care. Happy weekend. Bye.